Hi, and thank you for joining us. Today we will be discussing the basic principles of L.B. Foster's Wild IV Wheel Impact Load Detector and the hazardous conditions it can detect and prevent. Customer case studies and industry research will be reviewed to see the impact that the technology has had on railroad agencies. Presenting today is Jacob Capra, Product Manager, Wild Systems. Jacob has spent 10 years at L.B. Foster with previous roles in engineering and sales across multiple departments. You will see a Q&A panel at the bottom of the screen. Please submit any questions you have during the DemoCast, and they will be answered at the end of the presentation. And with that, I will pass it over to Jacob.
Thank you very much, Meredith. Good morning, everybody. Also, thank you to Progressive for hosting this DemoCast and allowing me to come and speak today. Like Meredith said, I'm Jacob Capra. If we haven't met, I'm Product Manager of Wild Systems here at L.B. Foster. And today I'd like to share a brief overview of Wild technology, some of the basic principles of operation, hazardous conditions that can be identified and avoided using it, and then the impact it's had on the industry, like Meredith said. So if you're unfamiliar with Wheel Impact Load Detectors as a technology, they're a wayside detector system. They're commonly used in freight environments. And the Wild 4 is a hardened data collection device. It uses a large array of strain gauges welded directly to the rail to measure stress and ultimately report forces at the wheel-rail interface. Now, users can set an impact threshold for these forces, or high impacts as we call them. And when they're exceeded, an alarm is generated that notifies personnel, and it'll allow them to take appropriate actions for that wheel, whether it's to monitor, to maintain it, or to replace the wheel that's been causing high impacts. So just an example of what this system looks like, how it operates, a basic overview of the hardware. You can see a standard wheel profile, and then a height and load from an apparent wheel defect. So this is an example of what would generate an alarm and be sent to personnel. Wilds play an important role in asset monitoring for many rail agencies. The high impacts that are detected by Wilds are an excellent indicator of hazardous conditions, primarily wheel defects. And if left unchecked, these repeated high impacts can lead to accelerated wear and even premature failure of track infrastructure and also vehicle equipment. So because of this, users utilize Wild data as a diagnostic tool, and it can provide insight into the health of their rail fleet, loading conditions on their rail, and also overall track stability. Wild technology is useful for identifying a lot of different wheel defects, tread surface defects like shelling, spalling, and also fracture, but also fatigue-related defects like flange and tread wear. The Wild 4 also acts as a weigh motion system, and this gives users the ability to determine wheel weight, axle weight, and also vehicle weight, and ultimately identify lading issues like overload and imbalance and shifted loads. Now, the Wild 4 is the only system on the market today that includes lateral force monitoring capabilities. And this allows the Wild 4 to identify oscillatory behavior in trucks that's common in truck hunting. And ultimately, by monitoring for and removing these high impact wheels and hazardous conditions, track and equipment failures caused by excessive loading can be avoided. Some common failures from excessive loading could include bearing failures, various kinds of rail breaks, and also joint bar and switch bar failures. Now, it's worth asking why a detector system is dedicated to measuring forces at the wheel-rail interface, and also why it's important to find high impacts there. To illustrate the point, consider a fully loaded standard rail car that's 286,000 pounds. And with even loading 8 wheels, the maximum wheel weight you would expect is just over 35,000 pounds. Now, for healthy wheels, the maximum load that wheel would impart on the rail is often very near the wheel weight, so also about 35,000 pounds. Now consider an AAR condemnable wheel. Those are those that exhibit loads higher than 90,000 pounds. Now, these wheels will need to be maintained or removed from service, but they're ultimately allowed to continue on track until the next available shop. And a wheel like this, the magnitude of load from a 90,000 pound impact is equivalent to a healthy wheel with 2.6 fully loaded cars stacked on top of each other. And we can actually go a step further than that. There's final alert wheels, and those exceed 140,000 pounds. By that same logic, if it was a healthy wheel, it would be the equivalent of about 4 fully loaded rail cars stacked on top of each other. And I bring this up to say that weight limits for track exist for a reason. Exceeding them by 300% or so means that you will definitely surpass the design limit of your tracks and your infrastructure, and you'll risk immediate failure of components. Now, you might be asking, if the Wild is strictly measuring forces at the wheel-rail interface, how is it identifying wheel defects? It is true that high loads at the interface can be caused by a lot of different conditions. Poor rail support, track geometry issues, rail defects. But there's a lot of industry research that shows that high impacts have consistently been an effective way to identify defective wheels. The research published by the FRA in 2019, that's the graph on the left, showed there's a direct relationship between wheel load and the size of the defect on that wheel. You'll also notice that the type of fastener support system under the rail matters significantly. There's similar research on the right from the International Journal of Rail Transportation, the graph that summarizes this. It shows that the dynamic wheel load increases with wheel flat depth. Now, the dynamic wheel load is the difference between the max load that wheel imparted and the expected load from the wheel weight. So essentially, the additional weight from the defect increases significantly as the defect, in this case, a wheel flat, becomes deeper. Now, this is where intelligent monitoring becomes really critical. There are many root causes of high forces at the wheel-rail interface, like I mentioned, but nearly all of them are track specific. Right. So as an example, if rail corrugation is causing excessive forces at the wheel rail interface, you would expect that if a consist passed over a Wild that had corrugated rail, that all the wheels would have excessive wheel loads. Right. And so if we find that a Wild measures a consist and only a single wheel has an elevated load, it becomes clear that the reason for the high impact is specific to the wheel and not the track. In other words, you likely found a defective wheel. And wheel defects are a hazardous condition in and of themselves. According to the TRB, wheel defects as a combined accident cause, code, or root cause are one of the leading causes of incidents in the rail industry. And this is what the rail industry has traditionally assumed that Wild technology can prevent: broken wheels, various types of wheel defects. But we actually believe that we can detect and prevent all of the incident and derailment causes that are on screen. Several of these incidents may be caused indirectly by wheel defects. The broken rails, bearing failures, like I mentioned earlier, all of these component failures can be caused by the high loads that result from the presence of wheel defects. In fact, there's more research also from the TRB that shows some of the most common failure modes of concrete ties. You can see the images on the left. Those are flexural and rail seat cracks. They're often caused by excessive wheel loads. We've also seen similar research from Sweden as recently as 2021, and it shows that as the number of high impacts from their Wild increased, the number of rail defects increased. And this implies that high impacts may be a root cause for the creation, or at least the propagation, of rail defects. And in fact, protection of concrete ties was actually the original motivation for the invention of the Wild back in the 80s, not identifying wheel defects. Amtrak had just spent $36 million upgrading the Northeast Corridor to concrete ties, only to find that many of them are cracking in less than a year. So they contracted Bell Laboratories to find the root cause of this, and ultimately that led to the invention of the Wild, and they used it to find that out of round conditions were leading to wheel loads over 100,000 pounds. And that's well beyond the design limit of these ties. So using this Wild, Amtrak found and removed these wheels, and not only did they stop cracking concrete ties, but the ones that were already cracked didn't propagate any further. Now, the FRA and TRB investigated this practice, this experiment, and what they found was that under the original loading conditions, those ties would have had an expected life of 15 years. But by finding them and removing them, they were restored back to their original design life of 40 years, an improvement of 60% for the lifespan of that asset. So we know that high impacts caused by wheel defects can lead to incidents or track infrastructure damage and equipment damage, but has the use of wild technology actually reduced the frequency of high impacts? Well, in 2022, the FRA published a comprehensive report on the effectiveness of wayside detectors, and this report included wild technology. So they queried interests, which tells you a little bit about how long ago this was. It was in the 2000s. They queried interests for a large population of cars and monitored the frequency of high impacts through the 2000s. And that time span is important because it's when wild technology was being heavily adopted, particularly by class ones, and the industry coverage improved greatly. And what they found was that condemnable wheels, which are again 90,000 up to about 140,000, those decreased by 85% in about a 9-year span. And final alert wheels, those that exceed 140,000, those decreased by over 90%. So we know that high impacts at the wheel rail interface are a problem. They're often caused by wheel defects, and wild technology has helped reduce the frequency of high impacts. But what most railroads are after is ultimately reducing incidents. So the question really is, did wild technology prevent incidents? Now, what I'd like to do is review how incident frequency has changed throughout that same critical time period, the 2000s, since the industry has adopted wild technology. And first, we should really establish all the types of incidents that a wild can prevent. And I've mentioned some of these already, right? There's track infrastructure related incidents, those from rail breaks, tie failures, joint bar and switch point failures. But then there's equipment related incidents. Those are wheel defects, also bearing failures, and truck hunting is actually the cause code for it is an equipment failure. Now, the FRA's Office of Safety Analysis keeps a really comprehensive database of all freight rail incidents. And this allows us to see how the frequency of these incidents has changed throughout the 2000s. What we find is that in a roughly 20-year time span from 2002 to 2020, during which wild coverage increased by a little over 200%, the frequency of all of these incidents combined decreased by over 60%. Now, another benefit of using the FRA's incident database is that you can look at accident cause codes in groups or individually, and so it allows us to look at just track-related incidents. And doing that, we can draw a few conclusions. First of all, it's damage to track infrastructure and not defective wheels that make up a large majority of the incidents that can be prevented by a wild. You can see in the 2000s, we were up at 400 to nearly 500 track-related incidents. And if I were to go back one slide, you can see that all wild detectable incidents were only about 500 to 600. So most of them are related to track. We can also see that wilds appear to have been most impactful just in terms of the number of reduced incidents, most impactful in reducing the frequency of rail breaks. And in fact, that same FRA report on wayside detectors that I mentioned earlier had a finding that was just the same. They looked at the most common track-related incidents. The top 4 causes were all different types of rail breaks. And what they saw was that in the 2000s, again, when wilds were being heavily utilized, the frequency of all of these types of rail breaks reduced significantly. Now, we can do the same exercise for equipment-related incidents, and we'll see that they've been reduced by a similar amount, about 65%. And those are driven heavily by wheel defect incidents and bearing failure incidents. You'll also notice that truck hunting has been virtually eliminated with 2 incidents or less every single year since 2012. And this data set ends in 2020, but I can tell you, having looked at the data, that carries on into 2025 as well. And maybe the reduction in wheel defects as a result of wild technology would not be surprising to anybody, but a significant reduction in bearing failure incidents, that might be surprising. It was a little surprising to me, and so I went and investigated that. You'll have to excuse the doorbell, I'm sorry. And what I found was a great case study. Many years ago at National Rail, they were experiencing a lot of bearing failures, about 24 a year, most in the colder months, and they theorized 2 root causes for the bearing failures: insufficient lubrication and excessive loading. So they tried a proactive lubrication regimen, And they didn't actually really get any meaningful results from that. So instead, they pivoted, they installed their first wild, and they conducted a study to see how wheel defects and their high impacts had an effect on bearing failures and the fatigue life of their bearings. Now, through use of this wild system, they had great effectiveness in removing high impact defective wheels. In a period of just 4 months, they reduced the presence of wheel defects by about 90%. And in that same time span, they had just a single bearing failure when on average they would have experienced about 8, perhaps even more than that, because many of the colder months were in this 4-month time span. So what they found essentially was that a 90% reduction in wheel defects for them led to about the same, 85% or so reduction in bearing failures. And there's more recent research that also supports this. In 2023, from the Railway Engineering Science Journal, they investigated the effect of 3 different wheel defect types on forces exerted on their bearings. And they found that certain defect types can produce a relatively significant increased load on the bearing. And this is important, even if only it's a 5 or 10% increase. Bearing forces often are, let's say, operating at very close to their fatigue limit. And a small increase in the typical loading on a bearing can have an exponential effect on the fatigue life. Now, last we could look at lading incidents, and this is primarily overload and imbalance of cars and containers. The decrease in these incidents is less pronounced, but it's still significant, down from about 35 to 40 in the 2000s to about 15 to 20 in recent years, a reduction of about 50%. So the industry-wide incident data shows pretty clearly that there's a correlation between wild usage and reductions in many types of incidents. And while the safety improvements from preventing these incidents, it has its own merit, railroads ultimately reduce incidents because it saves them money. So just how much money has it saved? Well, when adjusted for $20-25, we can see that the total direct spend on the incidents, just the ones that I've covered today, has decreased significantly, as much as $269 million in 2005, down to $70 million in 2020. That's a reduction of 74%. But these savings are really only part of the picture. There are indirect costs as well, from train delays, fuel idling, and hits to your operational efficiency. And they're not considered in the direct cost, and at times they can be substantial and even dwarf the cost of the derailment itself or the incident itself. Now, RailTech in 2019 published a really comprehensive report that tried to summarize indirect costs for incidents and fuel idling and rerouting. And based on their findings, we would estimate that the total industry savings generated by wild technology is somewhere between $400 to $500 million a year. So whether it's investigation by wild owners, case studies, industry-wide data, or FRA wayside detector reports, the message is the same. It's that the wild is a critical safety solution for any rail agency. It offers significant savings by preventing hazardous conditions. It enhances safety, improves efficiency, and protects track infrastructure. Thank you for listening. And if there are any questions, I think now is the time.
Yeah, Jacobs, we had a few come through here. Heidi would like to know, how do you determine the location of an infrastructure or rail defect from the wild, meaning where that rail defect is located on the track?
Mm-hmm. So the wild, I wouldn't typically use it to determine a rail defect. We say that it prevents rail defects by reducing the load, for instance, on the rail. Now, we have seen in the past where we're getting excessive loading with every consist that goes over a wild, and it did indicate there was a rail defect, rail bumps, rail corrugation. So what we see is a really repeatable pattern across all wheels in a consist and over consist to consist, and that tells you that there is a rail defect there or something else. But the wild is only about 50 feet long, and so it's not really meant to be something that monitors any significant amount of track. It's really meant to be monitoring what's rolling over the track.
Someone would like to know, are you able to put together a saving calculator for my railroad specifics if we installed a wild?
Yes, yeah, absolutely. A lot of the data that was covered today is industry-wide and non-specific to customers. I mean, we did have some case studies, but what we have is essentially a tool that if you were to input some information, the types of issues you're experiencing, whether it's, rail breaks or, flat spots, the frequency of those kinds of things and what you typically tend to spend on them. And based on some, site characteristics, and we could help pick a good site, we can generate really a pretty comprehensive picture of how effective the wild can be at reducing these hazardous conditions and ultimately how much money it can save you. So yes, we do have that kind of tool.
Great. Paul noted here that the conditions in your presentation seem to be specific to freight. Is there a similar benefit for transit agencies?
Some of these do apply to transit agencies. I mean, every rail agency, wants to avoid damaging their track infrastructure. But for transit agencies, the loads are significantly lower. And so you don't often, even with wheel defects, you won't often exceed the design limit of your tracks. So usually the value for a transit agency is actually more related to catching the defects quickly on your wheels. They own the cars for the most part. And so when you catch a defect just as it's started and has not yet propagated or gotten very deep, then it gives you the opportunity to true it immediately. And it improves the ride quality. It reduces noise and vibration by not having, defective wheels with flat spots rolling around. But it also allows you to remove less material when you true that wheel and ultimately can extend the lifespan. And in fact, we've seen some reports in some of the FRA reports that I've mentioned today. We have seen reports from agencies both in the US and outside of the US that claim to be saving millions of dollars a year, or I should say up to $1 million or $2 million a year by using the wild to extend the wheel set lifespan on their fleet.
Great. Can wild detectors be integrated with other monitoring or software systems? And if so, how?
Yeah, we see class ones do this all the time. They have super sites. They'll have a hot box detector, dragging equipment detector, and a wild, and acoustic bearing. They might have some photographic system down the line as well. And they're taking all that information and curating it and drawing much more sophisticated conclusions than any one system could make on their own. So yes, the data, a lot of these operate on tag reader systems, and so it's really easy to correlate the data. So yeah, we see that all the time. Now, L.B. Foster doesn't have an API or software to facilitate that necessarily, but absolutely, the technologies do all complement them, each other.
Okay, we've got some more great questions coming in here. Are there any wilds that don't use the traditional strain gauges, or is the strain gauge the best way to go?
There are some systems on the market that do not use strain gauges. In my opinion, strain gauge technology is probably the best way to go. And, this is a critical safety system. You're avoiding conditions that can be extremely expensive, can be dangerous to people and communities. And so, in my opinion, accuracy and reliability and precision are paramount here. And strain gauge technology has consistently shown that it is the most accurate type of sensing technology to achieve this that's out on the market. The Wild 4 is the only wheel impact load detector that's currently wobble qualified, which means this is the only system that can generate industry alerts that authorize users to make a lot of decisions based on the alarm they get. And I think that speaks for itself in that there are no other sensor types, no other methods of transduction that have been used that have been approved for industry alerts today.
Great. How have wild coverage increased over the past 5 years?
I would say that it's been a marginal increase, especially in class ones at best. What we see is that most class ones strive to hit a large percentage of their fleet. They strive for a large percentage of their fleet to hit a wild every 2 weeks or 4 weeks, and that's been largely achieved. And as traffic patterns change and things like that, maybe there is occasionally a need for a new wild. but there's been, only a handful of new wild installations, at least that we've experienced over the last 5 years. Now, where we've seen more interest and growing coverage is in industrial operations and regional railroads and passenger agencies as well. Some of those, especially the first couple, rely on Class 1 networks for their wayside detector technologies. But what we're finding is that if they own a lot of tracks, right, or they're in critical environments where you might be carrying hazmat through urban or near urban environments or by communities, that it would really actually be very important for them to have a wild as well. And so that's where we expect to see more growth in the future, and where we've been seeing growth right now.
Great. Is there application for a wild within a rail yard?
Minimally. Yeah, I mean, the weigh in motion feature could be helpful in a rail yard, but really what you're interested in then, I guess, is a scale. The reality is if you go, slower than say 15 to 25 miles an hour, the wheel defect will not produce a meaningful change in the force on the rail. And so the wild won't actually find it. So it's not going to be useful for finding wheel defects, but in a yard, you'll find that you're overloading cars. You'll find imbalances and load shifts and things of that nature. And this is a place where we want to see the wild become, more impressive as well. We want to be dialing in our accuracy on the weight side and see if we can be, more useful in environments like that.
Great. Does L.B. Foster provide Wild 4 to industrial short line railroads?
Yes, yeah, we do. We've got, I'm going to say, 15 to 20 total tracks in industrial operations. They're really popular in, iron ore operations. And I think that's in part because in terms of industrial operations that utilize rail, iron ore is, in my opinion, the most analogous to a standard railroad. But there is value in, if it's grain or, some sort of agriculture, coal. It's really about how fast do you go, what are your loads like? If you operate at track speeds and you have heavy loads, if you have a lot of track infrastructure, a lot of mileage, then it's going to absolutely benefit you to monitor your wheels and make sure you're not beating up your tracks, make sure you don't risk incidents. And maybe even if you're the car owner, even in environments like that, save your wheels and defer any replacement or maintenance on them.
Will you introduce the THD function of your wild system in the future?
Yeah, I mean, it was covered briefly here. For those that aren't familiar, THD would be a truck hunting detector. And so in the past, we've had dedicated wild systems that were meant to be, essentially just a truck hunting detector. Now what we see is that, you get both, right? You're going to get the impact monitoring, and you can optionally include this truck hunting feature. And that's essentially achieved through lateral force monitoring. So yeah, I would say that we offer it today. It's seen as, an optional feature for the wild. It probably will not return to being a dedicated product where you just buy a truck hunting detector that's based on this technology, at least.
As most rail rolling stock equipment is interchanged, do the railroads exchange the data that is generated from their wild systems with adjoining railroads?
Yes, they do. And so I mentioned briefly that the Wild 4 is the only system on the market that is authorized to generate industry alerts. And that's why that's so important. So, the general architecture here is that railroads collect data with their wayside detectors. That data is ultimately passed, possibly through Interest, which is now just a database, but where it really goes is to RailLink. And that is an open database of wayside detectors that, all players in the industry can go and monitor. And RailLink will automatically, give you information on your car or your wheels, even if it wasn't your wild that found, say, a defective wheel or something you might want to monitor or maintain. So yeah, the main way that that data is shared is actually automatic, and it's through reporting directly to RailLink and then using that as a repository.
Great. Are the vertical strain gauges helping the hunting detection?
Yes, they are, because at the end of the day, what's ultimately what we're looking for is a large L over V. And if you're not familiar, it's large lateral forces relative to the vertical force imparted on the rail. And when the L over V ratio gets high, you have a tendency for wheel climb. And that was sort of the original impetus for looking into this. But what we find is that you get large L over V from other conditions as well, and truck hunting is one of them. And we more than just look for high L over V, but we look for high L over V in certain periodicities, right? So it might happen at the beginning of a wild site, but if we're going to see truck hunting, we would expect to experience it potentially multiple times and even intervals throughout the site. And that's, kind of the nature of how we're finding truck hunting.
We do have a couple other really good questions in here, but out of respect for everyone's time, we're going to, take a break with the Q&A, but we do have your contact information. We will, answer your questions here via email. And we thank you for your great questions, and I'll let Jacob wrap it up.
Thank you, Hannah. And thank you again to everybody that gave us your time over your lunch break, perhaps. And I really appreciate you being here. I appreciate the questions. Like Hannah said, we will absolutely answer your questions. If we didn't get to them here, we'll send up a follow-up email. And thank you all, and we'll speak again.